Okay, so we did our review of dosages yesterday or Monday, and we had our test on Friday for our graphing. So today we're going to start our unit on statistics. We're going to squeeze it into 5 classes here, so our test will be on Monday the 9th. So in 5 hours, we can get a basic overview. So we're going to start off with just some definitions. First thing in statistics that we really need to define is something called a population. Are you guys able to see my computer screen at your locations? No? Okay. The population is the group that we want to learn about. And this can be trickier to define than you might think. For example, right now we're in the middle of a presidential election. So if you wanted to know or wanted to learn about who might win the next presidential election, your instinct might be to say, well, we're trying to learn about the presidential candidates or trying to learn about the president. But that's really not what we're looking at. What's going to determine who's president is going to be the voters. So what we're really looking to learn about is the voters and the voting habits. And we're not really looking at all voters. We're only really interested in the ones that are going to vote or who will vote in the next presidential election. And that might be tough to predict. So sometimes that population can be a little bit fuzzy. Now, I'm leaving a little space here, and I'll come back to fill that in a second. Out of that population, we choose a sample. And a sample is a smaller group that is chosen from the population. Several reasons why we would choose a sample instead of studying the whole population. For example, if we look at our whole population for the voters, there are roughly 300 million people, citizens in the United States. About 70% of those are eligible to vote. So that's about 210 million, but let's just say 200 million voters. If I wanted to survey all 200 million voters, that would take me quite a bit of time. Even if it was a phone call, contacting 200 million people would take a lot of time. So let's say we don't want to do a phone call, so we're going to do a mail survey. We're going to mail a survey out to them. Well, postage to get to 200 million people would be close to $100 million. So you're looking also at money. Third, and we're not even going to write this one down, sometimes it's just not even possible. There's really no way you could actually possibly contact all 200 million voters because some of them just wouldn't respond no matter what. A third way is consistency. To be valid, data must be gathered under the same circumstances. Well, what do I mean by that? Well, let's say that you survey one person today and they say they're going to vote for candidate A. Well, then tomorrow candidate A goes on national news and says something really stupid or really offensive. And now that person has changed their mind. But you've already surveyed them. But the next person you survey, people you survey after that point, they did see that comment and they've changed their mind. So you have to get the study done in a small enough period of time that the circumstances are the same for everybody in the study, that the information available to everybody is the same and it hasn't changed over time. The fourth one that we're going to mention, the fourth major one, is not necessarily going to happen, hopefully, in our presidential study, but it's destructive testing. I worked for a while I helped set up machines for a while for a company that produced the aluminum cans for soda. And they had to do testing to make sure the cans were strong enough. Those cans were required to hold up to a certain amount of force from on top so that they could be stacked. And so what they would do is they would produce the can and then they would put it in a machine that would put pressure on it until it crushed it. And it would measure how much pressure the can held until it was crushed. Well, obviously here you cannot test every can, because when you test it, it destroys the can. So you would randomly select 1 out of every 100 or 1 out of every 50 or whatever to test to see how much weight it can hold, how much force it can hold. So when we gather this information about a sample, the pieces of information that we gather about the sample are called statistics. Technical definition of a statistic is something that describes a sample. If we gather information from a population, or if we use our statistics to make a statement to describe the population, a piece of information that describes the population is called a parameter. So we've discussed why we can't work with the whole population. Some of the reasons why at least we have to take a sample. Let's look at sampling more specifically. To be useful, sampling must be what we call a representative sample. What that means is the statistics that we take from the sample. I screwed that up really bad. Let me try that again. Statistics that we take from the sample don't have to be exactly equal to, but have to be pretty close to the parameters of the population. So how do we, for example, let's say that 40% of voters are going to vote for candidate A. But we take a sample, and in our sample, we get 65% are going to vote for that candidate. That's probably not a good sample. Now, there are errors that are going to happen in here. There's what we call sampling errors, which is what we're trying to avoid. And sampling errors is the difference between our statistics we gather and the actual parameters. So for that example I gave, 40% of all people were going to vote for candidate A, but our sample said 65%. That's 25% sampling error. So how do we avoid those sampling errors and we can't guarantee a representative sample, but we can increase the chances, increase the probability of getting a representative sample. And how do we do that? Well, the first thing is sample size. I cannot call 2 people and ask them who they're going to vote for, and one of them says they're going to vote for candidate A. So I say, hey, 50% of people surveyed are going to vote for candidate A. That is not a good sample, way too small. There are all sorts of rules out there, rules of thumb they're called, for determining how big the sample is. Most of them require that you know the size of the population, which in some cases is not possible. And some of them are just set numbers. Some say the size of the population is represented with the small letter n. So some say that n just has to be greater than or equal to 30. That came about in statistics because certain probability distributions that represent numbers, if you're dealing with natural numbers, seem to fall into place if you have at least 30 in the sample, called the normal probabilities or normal distribution. But that might not always be adequate. Some, if you let capital N be the size of the population, say that N must be at least greater than or equal to 5% of the size of the population. So if you have 200 people in the population, you should sample at least 10. Well, there's still a problem there with 200 million voters. That's still coming out to where you should sample 10 million people, which is a pretty large sample. So obviously that rule of thumb wouldn't hold when you have a huge sample. And there are others out there that go by the square root of capital N and stuff like that. We're not going to get into them. For our purposes, just know that the sample needs to be sufficiently large. You can't just gather from a couple of people. Why is it that that sample size is so important? Well, we have what's called a distribution. And a distribution is how the numbers fall. Let's take a look at this. Let's say we're going to do a distribution of test scores. Let's say this is 70, 80, 90, 100. I went a little too far there. And, of course, in between. So let's say one student scores an 84. We'll put a dot over the 84. Another one scores a 92, an 89, 94, 97, another 92, 88, 93, 91, another 89, another 92, a 91, 93. And you can see as these dots build up, it creates a shape. We can draw a curve over the top of the dots that describes their shape. And as I mentioned, the whole normal probabilities, in nature, things tend to take on a bell-shaped curve, where the middle of the curve here, the point of symmetry, is the center. We're going to talk in a couple of classes about measures of center and how to calculate those. And then the width of it is called the spread or dispersion. And both of those can be used to describe the numbers in our population. Well, if I'm just randomly selecting one person from the population, it's real easy to get, or it's not unheard of to get one person that's has a really low value, or maybe one person that has a really high value. Let me draw that out again here. So let's say a randomly selected person has a really low value or a really high value compared to our center. The whole theory of taking a sample is, well, it's not uncommon for one person to have a really high or really low value. If I take a group of people, chances are the ones that are really small, if there's ones that are small or really small, there's also going to be some that are really large. And they'll cancel each other out and give us an average somewhere towards the middle. So the larger the sample is, the more likely it is that we have adequate number of large values and small values to cancel each other out. Okay, so now let's look at how do we select the sample. Looking at, if we determine what size sample we're going to take, how do we select it? The whole idea of selecting a sample is it must be random. A random sample means every member of the population has an equal chance of being in that sample. So let's discuss one. Well, let's discuss some methods of sampling. We're going to talk about convenience sampling. Let's say I wanted to know the average age of a WITC student. So I just walk out in the hallway, and the next 10 students that walk by, I ask them their age, I write it down, and I calculate it. That's a convenience sample. I gather the information that's easy to get to, that's handy for me to get to. The problem is, it's not a representative sample. Students who don't have morning classes, who only have evening classes, have no chance of being in that sample. Or students who are only online or only ITV have no chance of being in that sample. That is not a random sample. Now, another method that we might use, I might say, hey, you know what? I am going to take every class, take every class at WITC, assign every class a random number, and then select a certain number of classes. And then I'm going to go to each of those classes and survey everybody in those classes. That is what's called a cluster sample. So I've broken all the students down into groups, and I'm going to sample a whole group at a time. So that way, it gives me a little bit better, larger amount of information with less effort. It's also random because every class has an equal chance of being chosen. And I know there's things about class sizes and stuff like that, but we're not going to get that technical. So every member of the population has an equal chance of being chosen. We have to ignore the fact that there is a possibility of someone being in two different classes that both get selected, so they get repeated. We're just going to assume that they automatically pull themselves out of the second class. So that is random. So that is one valid way of gathering data. Another valid method, something called a systematic sample. Systematic sampling is used a lot in manufacturing. The example I gave you about the soda cans, the aluminum cans. In the systematic sample, let's say we decide we need to test every 100th can. But we're not going to test the first and the 101st and 201st. Let's say we randomly select a number between 1 and 100. And it comes out to be 97. So we're going to, then that means we're going to sample the 97th can and test it, the 197th can, the 297th can. So again, it is random because every can that is produced has an equal chance of being selected. Next, we're going to talk about stratified sampling. Back to my example of WITC students. There are four main campuses for WITC students. So I could divide it up into the four campuses and say, I'm going to survey 200 students, but I want to select 50 from each campus. So I divide it up by campus and then I select from within those campuses. Or I might even go further and say, okay, I want this many daytime students. So I'm going to select 30 during the day. I'm going to select another 15 in the evening and another 5 strictly online or ITV. So you've divided it up. Now, again, there's an issue of different sizes of campuses, number of students in each. So the assumption is made that it's divided up proportionally. Let's say that Rice Lake has twice as many students as Ashland. So we would select twice as many students from Rice Lake as we would from Ashland. So that we've done the whole weighting so that it's equal. So this is also random because every student has an equal chance of being chosen within their campus. The last one I'm going to put out there is something called simple random. This is the preferred method of sampling when possible. Simple random is definitely the best method of sampling. Obviously, since there's random in the name, it is random, but it adds another qualification to the random sampling. Rather than just every item in the population has an equal chance, every sample of the chosen size, we're just going to say of size n, has an equal chance. So our 200 students that we're going to select, the stratified sample is not simple random because it would be impossible to choose a sample where somehow randomly we got all the students happen to be from Rice Lake. That is a possible sample of size n, but there's no way we could possibly choose it with a stratified sample. A systematic sample is random but not simple random because, again, there's no way that you could select 2 cans in a row. You're selecting every 100th can or every 50th can or whatever you choose. Cluster sample, again, it's random but not simple random because there's no way you could choose a sample that had 1 student from every class. So simple random is considered the best way of randomizing, the least likely to have a sampling error. About the best way to describe how to do a simple random sample would be to either print off the name of every student in WITC, or assign everyone a number and put those numbers into a hat or a bin or whatever, and draw out names or numbers for those students. That way, every student has equal chance, and every possible group of that size has an equal chance of being selected. So it's kind of it feels like a weird distinction, but it is a big difference, the simple random sample. Okay, so enough about sampling. Sampling is very important, but once we've selected our sample, it's time to gather data. And when we go to gather data, we have to define our random variable. And the best way to define the random variable is the random variable is the answer to a question. So if we're asking who do you plan to vote for in the next election, the answer is the name of one of the candidates. So the random variable is the name of the candidates. Do you support a certain law? Yes or no is your answer. That's your random variable, is your yes or no response. How old are you? Your age would be a random variable. It's a number. So when we look at that random variable can either be what we call categorical, or sometimes called qualitative. Qualitative because it's describing a quality of somebody and not a quantity. Categorical because it puts you into a category. Categorical questions, of course, are all yes or no questions because it puts you in a category. You're yes or you no. You're in favor or not in favor. Other things would be like favorite color. That would be categorical. Whatever color you list off puts you into a category. Favorite make of a vehicle, Chevy, Ford, Dodge, whatever, puts you into categories. Categorical data can be nominal, where it's just separated by name only, like your favorite color, red, blue, green, purple, whatever. There is no way of putting them in any sort of order, so they're just by name only. Or maybe, what's your favorite fast food restaurant? McDonald's, Wendy's, Burger King, Hardee's. Again, by name only. Or a categorical variable, maybe ordinal. Ordinal means it can be put in an order. For example, if they ask what size soda you usually order at the fast food restaurant, small, medium, and large can be put into order from smallest to largest. If we ask you what your letter grade is in a class, A, B, C, D, or F, again, whatever letter you give puts you in a ranking as being better or worse on the scale of the grade scale. Next, we're going to talk about numerical data. Numerical, sometimes called quantitative because it's a quantity. So with numerical data, the answer to that random variable is a number. And that number can be one of two things. It can be discrete, or it can be continuous. Now, there's a lot of different definitions for discrete and continuous. The definitions I use, because I think they're the simplest, discrete is an answer, a numerical answer that can be counted. If you're asked how many cars does your family, or how many cars are there owned in your household? You either have 0, 1, 2, 3, 4 on up. You don't have half a car. I know some of you may say, well, this one doesn't run, so I'm going to count it as half. It's either a car or it's not in this case. How many children do you have? Same way. 1, 2, 3, 4. You don't have half a child. So things that are counted are discrete. Continuous are things that are measured. Your height, that's continuous. Your weight would be continuous. Age is a tough one. Time is often considered to be continuous, but you can make the argument, well, it's broken down into seconds and you count the seconds to create time. So that one I could go either way with. Another one that could be, well, one of the definitions of continuous is no matter how close two values are to each other, you can always find one in between. For example, if you're talking about height, no matter how close two people are in height, you can always find somebody that's between them in height. But if you look at that, that's kind of vague because, again, you look at things like money. Is money continuous or discrete? Well, money, you can find dollars in between if you're doing electronically, but it is still measured in pennies, and you count your pennies. So I would classify money as discrete because it's not measured, it is counted. Okay, so now within those classifications, there are three levels that we have. We have ordinal. Ordinal, again, is just putting them in order, just like with the categorical variables. Is it ranked 1, 2, 3, 4, or how many stars does the restaurant get in this ranking? 1, 2, 3, 4, 5 stars. You can definitely say that a 5-star is better than a 4-star, but not how much. There's what we call interval. Interval measurement is where the difference matters. You might look at somebody whose height might be a good one. That's kind of fuzzy, but nobody out there is 0 inches tall, so there is no 0 point. That's one of the things that's a characteristic of interval measurement. There's no 0 point. So nobody is 0 inches tall. So if you have a person who is 56 inches and a person who's 60 inches, the 60-inch person is 4 inches taller. But if you have another person who is 62 inches and someone who's 66, the 66-inch person is 4 inches taller. That 4-inch difference is the same no matter where along the scale it is. The intervals are meaningful. The 4-inch interval is a 4-inch interval no matter where you are along the scale. But you cannot take someone who's 30 inches tall and someone who's 60 inches tall, and you could say they're twice as tall, but it doesn't make sense because there's nobody out there who's 0 inches tall. Ratio is where there is a natural 0. So money, there are people out there that have 0 money. In fact, there are people that have negative amount of money. But somebody who has $20 does have twice as much as somebody who has $10. Somebody who has $40 has twice as much as somebody who has 20, and so on. So you can say twice as much because there is a natural 0 point for that variable. So once we have our data here, or once we've defined our variable or question here, we have to look at how we're going to gather it by selecting the sample and how we're going to select that sample. If we're going, most of the time, if we're looking at a population, if we're trying to gather information, just gather from people and so on, it's called a census. In a census, you're gathering information from every item in the population. Many of you have probably heard this term, the U.S. Census Bureau or the U.S. Census. Occurs every 10 years. There'll be another one coming up here in 2020 where they try to gather information about every living person in the United States. If it is a sample, the process of gathering that information is called a survey because we're only gathering it from a small portion of the population. One thing to warn about on the surveys, I didn't put it, it is actually technically a type of sampling, but something to be careful about there is self-selection. And self-selection is very, very tough to avoid. 99% of the surveys you see on television or the news are self-selected samples. I don't know, most of you have probably at some point sat at home and either you got a call or your parents got a call, and it came on the line, hey, this is Joe from blah, blah, blah company. Today we would like to ask you to take a short survey for us, or would you like to take a survey? Or you've been at the mall or something, you've been approached with a person carrying a clipboard. Would you like to take a survey for us today? You have the option of saying no. You can hang up the phone, or you can say no and walk away. You don't have to be a part of that survey. A lot of times at the beginning of the survey, they'll say, I am from this organization, or the survey is about this. So the only people that would, or many times the largest number of people that would stick around and take that survey are ones that are passionate about that topic, or ones that have nothing better to do and figured it'll pass some time, right? So self-selecting is bad. It gives us skewed results. An example of this, I worked for a period of time at the UW-Madison Statistical Research Center. And they did surveys, they designed surveys. One study I did, just to prove a point, was we sent out 1,000 surveys. We got permission from some political campaigns, some political parties. 500 of them went out in envelopes labeled from the Democratic Party of Wisconsin. Another 500 of them went out in envelopes labeled from the Republican Party of Wisconsin. Now, for each of them, I only got back around 100 responses, about 1 in 5. But you can guess the ones that the survey itself was identical with just a little symbol up in the corner to let me know which envelope it had been in. If you're Democratic and you get an envelope that's labeled Republican Party of Wisconsin, what are you going to do with it? You're not even going to open it. You're just going to throw it in the garbage. So those surveys that went out in the envelope labeled Republican Party of Wisconsin came back with very conservative, or what you would expect from people with Republican beliefs, responses to that survey. Because those that were Democratic or were associated with the Democratic Party most likely threw them away or didn't even look at them. The same way went the other way around. If it went out in an envelope labeled Democratic Party of Wisconsin, those responses came back with much more liberal responses, because someone that would associate with the Republican Party would get that envelope and not even open it, most likely toss it. They don't want to look at it. So those results can be skewed that way. Another thing that is done, I want to talk just a little bit about ethics, because we could go on for days about ethics and statistics, but a little bit about ethics is some things that are done to, skew the data a little bit. One thing that can be done is stacking surveys. And this is very, very common. The system we used for the Statistical Research Center was all on computer. The people that were doing the surveys were a lot of times work study or other students that were paid a certain amount. All they did was they had the phone headset on and they read what came on the computer screen. They pressed a button or clicked on a spot when they're ready to make another call. The computer selected the number to call, it made the call, and it put the particular survey up in front of the person, and they read on the computer screen what they were supposed to say. And then they entered the response, and there were codes for the response, whether yes or no or multiple choice or whatever it was. There were ways to code that response in. And so they took the response, and then the computer put up the next question for them to ask. And they entered that response in, and so on. Well, some of the surveys were programmed to ask 3 to 5 questions. And at the end of those 3 to 5 questions, the computer made a choice. Either it put up the message to read of thank you for your time, blah, 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 have a nice day. Or put up the message, just a few more questions. Well, why do you think some people got more questions and the others got sent on their way? Well, because based on the answers to those first few questions, the program had been programmed to determine that they were going to answer in a way that they wanted you to answer. Let's say a lot of companies are required to put out surveys for different things, sometimes environmental concern surveys and other things. So let's say I'm a company that wants to put out a new product that might have a slight environmental impact. Maybe it's like televisions have microchip semiconductors in them and it's considered a hazardous material. You cannot just throw a television in the garbage can. There's silicone and germanium in there that are considered hazardous. So this company wants to put out a product that has some slightly hazardous materials in them, so they're going to do an environmental impact survey. So they're going to survey, and if the survey comes out too low, they might not get approval to market their product in a given region, whether it's state or whatever. So they're going to do a survey to prove that the people in that area don't have a problem with their product. So what they might do is they might ask questions about do you consider yourself to be environmentally active? Do you recycle? Things like, do you consider, they might ask about television, semiconductors and televisions to be a major polluting factor and things like that. And then once they've got to that point, the computer decides, hey, this person is very concerned about the environment and thinks that a lot of these materials are bad. We're going to end it here. We're going to just stop. Or this person is not so concerned about the environment. They think that the benefits of these products outweighs the potential cost to the environment. So now we're going to ask them about our product and what they think. So they've stacked those surveys to kind of hand pick the people that they want to take the real survey. Okay, so the next thing we're going to talk about, and we're going to wait till Friday to talk about that, is we're going to talk about how do we organize, once we get the data, how do we organize it? We've talked about the distributions a little bit, so we can organize it into tables and graphical representations of information. And then we'll move on from there of how do we describe it numerically? How do we summarize it numerically? And that'll probably be next Monday that we'll get into that. We'll talk a little bit then about how do we analyze data and stuff like that. What do we do with it once we've got it analyzed? What do these numbers all mean once we calculate them? There's a lot to it. And then, like I said, we'll be looking at our test on the 9th. So with that, it looks like Schwamigan's going to have to go real soon. So we'll cut it off. There is no homework for today. The textbook doesn't, no use going through the definitions and stuff, so the homework won't start till tomorrow, or till Friday. So we'll leave it at that. You guys have a great day.